Let's discuss this geometric problem which says in triangle ABC the altitude CD, the angle bisector CE, and the median CF. From the point C, divide the angle C into 4 equal angles. We need to find the angles of the triangle. So this is 90 degree and CE is the angle bisector. First let us make all the 4 angles to be equal. CE is the angle bisector. That is also quite evident because these two angles are becoming equal, 2 theta, 2 theta, and CF is the median, so F is the midpoint of AB. Now one construction have already been done out there. Let me quickly go through it. That is from the point E I have dropped a perpendicular on the side BC, so this is again 90 degree, and M is the foot of perpendicular. Then CA is extended and MD is extended to meet at the point N, and NE is joined along with AM is joined. Now let's study the figure out there. You see that since from E we have dropped a perpendicular on BC, so this angle is 90 degree and this angle is also 90 degree, so we can see that CMED, this has to be a cyclic quadrilateral. CMED is definitely going to be cyclic because we are getting two opposite angles which are 90 degree. CME is 90 degree and CDE is 90 degree, so CMED is cyclic. So from the figure we can claim that angle CMD must be equal to angle CED. Due to the cyclic nature, CMD should be equal to CED, and you can see that this particular angle is 90, this is theta, so CED is 90 minus theta, and similarly this is 90, this is theta, so CAD is also 90 minus theta, so we can safely claim that this is also equal to CAD. So CMD is equal to CAD. So in the figure we see that the triangle CNM and triangle CAB, they are similar triangle. They are similar because you see that we are having three angles are equal. Like C is the common angle in the triangle CNM as well as CAB. C is the common angle, and you see that we have proved that CMD is equal to CAD, so these two angles are equal, and so we can see that C is the common angle and the other pair of angles are also equal, so the two triangles are having three equal angles, so they has to be similar. So they are similar triangle with C as the common vertex. Okay, so C as the common vertex. So you can see that since they are similar, so we can claim that they are similar and they are sharing this bisector CE, like in the triangle CNM. Interestingly, the bisector is again CE. So CE is the common bisector for the two similar triangles. So like you see that CF is the median for the triangle CAB, and that CF is at an angle theta from the angle bisector CE. And since the angle bisector CE is common between the two triangles, so from CE on the other side we are having at an angle theta, we have got CD. So CD can be claimed to be, so we can claim that CD is a median of the triangle CMN due to similarity. Okay, because CE is the common angle bisector for the two triangles, CF is the median of the triangle CAB, so similarly CD must be the median of the triangle CMN. Now CD is the median, so CD is the median, that implies that MD equal to ND, so D is the midpoint, and from the figure we can also claim that AD is equal to ED. Okay, AD and ED, they are also equal. this is theta theta, this is 90. So these two triangles are congruent because they are having a common side, so they're congruent. So we can say that AD must be equal to ED. So AD equal to ED and MD is equal to ND. That means that we can say that AMEN, this quadrilateral, must be a parallelogram, because AE and MN, they are having a common midpoint, that is D. They are bisecting each other. So ANEM, this parallelogram must be, this quadrilateral must be a parallelogram. And so let us come here. AMEN is a parallelogram, and since it is parallelogram, so we can safely claim that AN is parallel to ME. AN is parallel to ME. Now ME is perpendicular to BC according to our construction. ME is perpendicular to BC and AN is parallel to ME. So this automatically implies that AN must be also perpendicular to BC. Okay, AN is perpendicular to BC. Now since AN is extended portion of CA, so we can actually say that CA is perpendicular to BC. So CA is perpendicular to BC means this angle turns out to be 90 degrees. So angle C turns out to be 90 degree. So the angle theta turns out to be 90 degree by 4. So that is 22.5 degree. Once we get theta to be 22.5 degree, we can easily find out this particular angle to be 90 minus 22.5 degree, that is 67.5 degree. And since this is 67.5 degree, this particular angle should be 22.5 degree. So our final answer is going to be, the angles of the triangle are 90 degree, 67.5 degree and 22.5 degree.